Okay, now write down today topic integration by parts. Integration by parts. Integration by parts. Okay, definitely in your exam paper, integration by parts will be there. Very important part. Usually part B question, there will be integration by parts question. So again identify. So we don't know how to integrate logarithmic functions. Again, we don't know how to integrate inverse trigonometric functions. No? Inverse trigonometric functions, we don't know how to integrate. And also logarithmic functions, they are known. Still, we don't know. Therefore, to integrate those logarithmic functions and to integrate inverse functions, usually we use integration by parts. And also, if we have product like ex times x, sin x times x squared, xln x. Likewise, those functions, to integrate those functions, we use integration by parts. Then if we have different function product, then we need to use integration by parts to separate it. That's the thing. Okay, just write. To integrate product of two functions. To integrate product of two functions. To integrate product of two functions. Usually integration by parts is used. Usually integration by parts is used. And also to integrate first one logarithmic functions. Second one inverse trigonometric functions. Inverse trigonometric functions. Third one sin x, sec cube x cosec cube x. And sec and cosec odd powers integrations. Sec and cosec odd powers integration. Then sec cube, cosec cube, sec to the power 5, cosec to the power 5, those things. Huh? Sec, cosec odd powers. Then fourth one, product of two functions. Product of two functions. Especially here, first one, polynomial times log, polynomial times exponential, polynomial times trigonometry, then exponential times trigonometric. These are different products. Huh? These are different products. We usually use integration by parts method. Huh? Okay. For these cases, we use integration by parts. Okay, we will analyze one by one. Huh? We will analyze one by one. Okay, now we know when differentiating two functions, you consider uv functions of x, uv functions of x, then uv product derivative duv over dx equal u times dv divided by dx, v times du divided by dx, no? V times du divided by dx. Therefore, now I'm going to integrate this. I'm going to integrate now. Integrate with respect to x. Then d uv dx dx u dv over dx dx v du over dx dx. Let's take this integration. So now you can remove this dx. By the definition, you can remove this dx, not just division. By definition, we can remove. Therefore, duv integral u dv integral v du. So when you subject this part, v du we call, before that here derivative need to integrate, then we get uv function u dv plus v du. Now subject this one, v du part we call uv minus u dv integral. This is we call fundamental things about integration by parts. Okay. By this definition, we convert product in product. We remove that product. Later we will see how to apply it. Before that, just write it. Just write this one. Okay. Now it's star mark, write down. To integrate logarithmic functions, integration by parts is used. To integrate logarithmic functions, integration by parts is used. To integrate logarithmic functions, integration by parts is used. Okay, now say this, Anna. Here ln x. So first, say this one. First, You see this view. Here v and the other part du. Then you take this logarithmic function as v, take the other part du, v and du. Okay. Usually v function must be differentiable function and the other part must be integration type. Therefore, v equal ln x dv over dx equal 1 over x. Likewise, you can differentiate. Therefore, v dv equal 1 over x dx. Then du equal dx. Then here v du, instead of v du, we write uv minus udv. Then we have v, then you differentiate, find dv. So here we need u again. You have du, then to subject you need to integrate. No? Then integrate both sides, du dx. Then u equal x. U equal x. Now, instead of this part, you say uv minus udv. Then u value x, uv multiply x ln x minus integral u dv. Here u value x, dv value 1 over x dx. Then cancel x, x ln x. Here dx integral we call x. So this is indefinite integral now. Then you put arbitrary constant here, arbitrary constant. But here we have done some part of integration, but don't put constant, arbitrary constant here. But that effect you can put arbitrary constant from here. Here C, here C. Okay. Then that's how we integrate logarithmic function. Logarithmic function. Okay, do it now. With star mark write down, always select logarithmic function as v. Always select logarithmic function as v. Okay. Okay, now say this. Now combination with logarithmic function, you select v as logarithmic function. Okay. If you have combination with logarithmic function, take v as logarithmic function. That's the thing. Now consider x ln x. So here polynomial times logarithmic function. No? Then I told you take logarithmic function as v. Then take here v ln x x dx. Likewise rewrite it. Here take this part v, the other part you take du. Therefore v equal ln x du equal x dx. Because we don't know exactly, directly we don't know how to integrate logarithmic function. No? So we need integration by parts. That's why we take v function as logarithmic function. Now differentiate dv divided by dx 1 over x, then dv equal 1 over x dx, then integrate du integral x dx, then say u, here x power over 2, x power 2, don't put arbitrary constant, right? Still we haven't done integration properly, here just subpart. No? Then instead of this write uv minus u dv integral, here uv, then x power over 2 ln x minus u dv, u mean x power over 2, dv mean 1 over x dx. So we did integration here, therefore that effect you put arbitrary constant from here. Okay. Then cancel one x variable, x power over 2 ln x, take half outside, x dx plus c1. Then x power over 2 ln x minus 1 over 2 x integral x power over 2 plus another arbitrary constant c2. Here one arbitrary constant because of this integration. Thereafter we do another integration, then change arbitrary constant c. Then x power over 2 ln x minus x power over 4 plus c. Okay. Then මෙතන c1 එකක් තියාගත්තට කමක් නැහැ. Then c1 plus c2 you say new arbitrary constant c, or otherwise you put arbitrary constant c here, then same c you can take. c1 c2 කියලා දෙන්නෙක් ඕනේ නැහැ. You can just take just c. Okay. Do that example. Okay. Now you continue. ln x plus 1, ln 2x minus 1, x ln x, x plus 2, 2x plus 3, ln x minus 1 dx. Okay, start doing this. So remember, take logarithmic function as v. Take logarithmic function as v. Then the remaining part take du. Then you find dv and u and get that formula and continue. So after doing this integration by parts, when it come to here, then no product we can see, no? No product. That complicity has gone. Therefore, you can proceed now, no? Continue now. Take the time. Okay. ln x plus 1 dx. Take v ln x plus 1 dv 1 over x plus 1 dx. du equal dx, then u equal x. uv x ln x plus 1 minus u dv x of x plus 1 dx plus c1. Then x ln x plus 1 minus here rational type, no? Rational type. Then get division algorithm. 1 minus 1 over x plus 1 dx plus c1. Then you can integrate, no? x ln x plus 1. Here 1 integral x, 1 over x plus 1 integral ln x plus 1. Here no need to put modulus because initially given without modulus, no? Therefore, its domain will be positive value. Therefore, within logarithms must be positive. Therefore, domain has selected, it is given. You can consider that as given. But if you need to integrate this type of thing directly, then definitely you need to put modulus. But this case no need because initially it has defined. Then here modulus not compulsory. Then C2, C1. Then x ln x plus 1 minus x plus ln x plus 1 plus c. Likewise, we can do. Then ln 2x minus 1 integral. Take v ln 2x minus 1 dv 1 over 2x minus 1 times 2 dx du equal dx u equal x. Then uv product x ln 2x minus 1 integral 2x over 2x minus 1 dx plus c1. x ln 2x minus 1 minus here 1 minus 1 plus 1 over 2x minus 1 dx plus c1. Then x ln 2x minus 1. Here check this one. 2x minus 1 plus 1. We get 2x over 2x minus 1. If you can't write directly, just get ln division. Ln division and write division algorithm. Then integrate now. Here minus 1 integral x. Then 2x minus 1 we say ln 2x minus 1 modulus divided by 2. Then plus c. Plus c. Complete. Okay. Then x square ln x dx. Take v ln x dv 1 over x dx du x square dx u x cube over 3. Then uv product x cube over 3 ln x minus 1 over x cube over 3 dx plus c1. X cube over 3 ln x 1/3 x square dx integral c1. Now do integration the remaining part. X cube over 3 ln x 1/3 x cube over 3 plus c2 plus c1. Then x cube over 3 ln x 1 over 9 x squared c. Continue. Last one, 2x plus 3 ln x minus 1. 2x plus 3 ln x minus 1. Then take v function ln x minus 1 dv 1 over x minus 1 dx. මාර ස්ටෙප්ස් දෙකක් විතර ගත්තේ නැහැ. කෙලින්ම ලිව්වා v derivative side dv x side derivative just differentiate and multiply by dx. Then du equal 2x plus 3 dx. Then you integrate this x square over 2 plus 3x x square plus 3x times uv ln x minus 1 integral here x square plus 3x over x minus 1 dx plus c1. Now it is rational type integral. Then get log division and proceed. Then x square plus 3x divided by x minus 1. Here x square minus x. Here 4x plus 4. 4x minus 4. 4. Then you can do this. X square plus 3x ln x minus 1. Here quotient x plus 4. And here remainder. Plus c1. Then x square plus 3x ln x minus 1 minus here x square over 2 4x here denominator x minus 1 then ln x minus 1 modulus plus c. Here x derivative x integral x square over 2 4 integral 4x 4 over x minus 1 integral ln 4 times ln x minus 1 modulus. Here also no need to put modulus because initially function defined. Initial ln function defined. Therefore, definitely selected domain must be given. Therefore, don't worry about putting modulus here. Complete. Let's do another few exercises. You continue. ln 2x plus 1 x plus 1 times ln 2x plus 1 integral. Then x bar plus x minus 1 into ln x integral. 2x plus 5 log ln x dx log 10 base x integral. Let's continue. You try. First three similar type. Last one need to simplify before integrating it. Okay, start. Take time. do alone. If you have any doubt, just do with me. Here for this, v equal ln 2x plus 1 dv 1 over 2x plus 1 into 2 dx du x plus 1 dx, then u x power over 2 plus x, then uv product, then here integral x plus 1 ln 2x plus 1 dx, then uv product x power over 2 plus x into 2 over ln 2x plus 1 minus integral product of these two x power over 2 plus x times 2 over 2x plus 1 dx plus c1. c1. Okay, similar technique. Use logarithmic function as v. Okay, remember that. If you see logarithmic function, definitely use logarithmic function as v. If you have seen inverse trigonometric function also, we select v function as inverse. Continue now. X power over 2 plus x ln 2x plus 1, here minus, here take common denominator, x square plus 2x cancel to 2x plus 1 dx plus c1. Now get log division, x square plus 2x over 2x plus 1, put 1 over 2x, then x square plus 1 over 2x, subtract 2 minus half, 3 over 2x, then plus 3 over 4, then 3 over 2x, 3 over 4. So when you subtract, we get 3 over 4. Therefore, right algorithm, x square over 2 plus x ln 2x plus 1 minus here 1 over 2x 3 over 4, here this part 3 over 4, 2x plus 1. Now you can integrate separately. No? You can integrate separately. X square over 2 plus x ln 2x plus 1. Here 1 over 2x integral 1 over 2 x square over 2. 3 over 4 integral 3 over 4x. Here minus common, put bracket. Then 3 over 4. Then 3 over 4 denominator 2x plus 1 linear type. Then ln 2x plus 1 divided by x coefficient 2 plus c. Arbitrary constant c. Take time. Okay. Then x square plus x minus 1 over 1 times ln x dx, this part. You take ln x function v, the other function du. Okay. Then here x square plus x minus 1, x square plus x minus 1 ln x, take log function v and the other function du. Then find dv and u. Okay, now proceed. uv x cube over 3 x square over 2 minus x ln x u dv x cube over 3 x square over 2 minus x 1 over x dx plus c1. And remember, always dx right hand corner. හරිද? මැද ලියන්න එපා. Always get right hand corner. Then simplify. X cube over 3 x square over 2 minus x ln x. Here cancel one x term, x square 1/3 x square dx minus 1 over 2 x dx plus dx. Now you can separately integrate, no? X cube over 3 x square over 2 minus x ln x 1/3 x cube over 3 minus 1 over 2 x square over 2 plus x plus c. Okay, continue. Similarly, the other case, 2x plus 5 ln x, 2x plus 5 ln x, v equal ln x, dv 1 over x dx, du 2x plus 5 dx, integrate u 2x square over 2 5x. Then uv x square plus 5x ln x 1 over x x square plus 5x dx plus c1. Then x squared plus 5x ln x minus x plus 5 dx. Then integrate x square plus 5x ln x minus x square over 2 plus 5x plus c. Complete. then log 10 base x, log 10 base x. Log a base b, we write log e base b over log e base a, logarithmic theorem, then ln b over ln a. Therefore, integral log 10 base x dx, here write ln x over ln 10. Then ln 10 mean constant, take outside 1 over ln 10 ln x dx. Now we have logarithmic function. No? Then you use integration by path technique. We know usually v function ln x dv 1 over x dx du dx u equal x. Then uv 1 over ln 10 x ln x u dv 1 over x dx. This part we have done previously. No? Now integrate that part. 1 over ln 10 x ln x, here x. See, you can simplify. Yeah? That's how we do. Then if you have different bases, you convert that into e base. Then do integration. Complete. Okay. Now integrating logarithmic function, we use integration by parts. No? When integrating logarithmic function, we use integration by parts. Then likewise, you remember when integrating inverse trigonometric function, again you need to use integration by parts. Okay. Okay. Which star mark write down? When integrating inverse trigonometric functions, when integrating inverse trigonometric functions, use integration by parts. by taking v as the inverse function. V as the inverse function. Okay. Okay. Now let's do example. Y equal tan inverse x, tan inverse x integral, tan inverse x integral. So up to now we know integrate ex, x to the power n type, constant, then 1 over x integral, x to the power n integral, no? Sine cos integral, then tan cosec sec cot අපි වැළුව කලින් using ln. Then further we know sec qua x, cosec qua x, sec x tan and cosec cot. Those integrals are known. Then inverse function integral is exactly we don't know. Exactly we don't know. Then here this case you take v function tan inverse the other part du. Then v function tan inverse x dv differentiate 1 over 1 plus x bar dx du equal dx, then integrate u equal x. uv, instead of this write uv, x tan inverse x minus u dv, then x over 1 plus x bar dx c1, then x tan inverse x, then denominator derivative, that is 2x, no? Then you put here half integral 2x 1 plus x bar dx plus c1. Then we have denominator derivative, then use ln. Then x tan inverse x 1 over 2 ln 1 plus x bar plus c. In this part we have denominator derivative. Likewise you can do. So anyway, remember for inverse trigonometric functions use integration by parts. That's it. Okay, do that example. Continue. then x tan inverse x. X tan inverse x. Here v function tan inverse dv 1 over 1 plus x square dx du equal x dx u x square over 2. Then uv u dv. Then x square over 2 tan inverse x. Take half outside. Then for this part, 1 minus 1 over 1 plus x squared. Then x square over 2 tan inverse x 1 over 2. Then integrate. One integral x 1 over 1 plus x square integral tan inverse plus c. Good brackets, huh? Continue. Take always inverse function as v. Take always inverse function as v. Huh? Then you can proceed. Okay, then x square plus 1 into tan inverse x. Then v function tan inverse dv 1 over 1 plus x square dx, du function x square plus 1 dx, then u function x cube over 3 plus x, then uv product x cube over 3 plus x into tan inverse x minus integral x cube over 3 plus x over 1 plus x square dx c1, x cube plus x, 1/3 x cube plus 3x x square plus 1. So here rational type, no? Rational type integrals we know. Then you need to get log division. Then do separately. X cube plus 3x need to divide by x square plus 1. Put x here. X cube plus x subtract. Then division done. X cube over 3 plus x. Tan inverse x 1/3. Here write x plus 2x over x square plus 1. Then you can integrate this. X cube over 3 plus x. Tan inverse x 1/3. X integral x square over 2. Here ln x square plus 1 modulus plus c. Here c1, then it changed to c. Okay. Complete. Then remember, inverse trigonometric function can integrated by parts, no? Then logarithmic function also same. Logarithmic function also same. ඔය points special මතක තියාගන්න. Put another star mark and write down. To integrate sec and cosec odd powers. Sec and cosec odd powers. Use integration by parts. Okay, now remember again to integrate sec and cosec odd powers greater than 1. Sec integral, sec cube, sec to the power 5, sec to the power 7, likewise cosec cube, cosec to the power 5, cosec to the power 7. Odd powers. We use integration by parts. Here the way. Consider sec cube. You take here sec x into sec bar x. Sec cube right, sec x into sec bar x. Then you take this part v function. Here this part du function, because we know sec bar integral. Sec bar integral tan. Then take this part du. Then v equals sec x. dv equals sec x tan x dx. du equals sec bar x dx. Then integrate u equals tan x. Sec bar integral tan. Then uv product. Here uv sec x tan x u dv minus tan x into sec x tan x dx plus c1. Okay. Then simplify further. Sec x tan x. Then tan square. Sec x tan square x dx. Then tan square equals sec bar minus 1. Simplify. Sec x tan x. Here sec cube. And here plus sec x. දැන් මෙතන මෙහෙම කේස් එකක් ආවා. දැන් sec cube එකනේ අපි ඉන්ටිග්‍රේට් කරන්න දන්නේ නැති ඉඳන් මේ කරේ. ඒතර ආයෙ ගියාම ආයෙ sec cube එකක් ගන්නවා. හරිද? දැන් මේක කොහොමද දන්නේ නැහැ sec cube එක. හැබැයි මේක හදාගන්න පුළුවන් මේ විදිහට. I කියලා ගන්න. I integral I. Then take this part I. Integral I. Take the other side. 2I sec x tan x. Sec integral ln sec x plus tan x modulus plus c. C2 c. Then divide by 2. Then I 1/2 sec x tan x ln sec x plus tan x plus c. මෙතන මේ 2 ගෙන් ඩිවයිඩ් කරනකොට c2 divide by 2 කියලා ලියන්න ඕනේ c කෙනෙක් මගේ. ආබිටර් කොන්ස්ටන්ට් එක. ඒකෙන්ද c ම just ඉවර කරනවා. just c ලියන්න. ඔය විදිහට. එතන මෙතනදී මේකේ ස්පෙෂල් එක මතක තියාගන්න. මේ ඉන්ටිග්‍රල් එකම අපව හදන්න. ඊට පස්සේ ඉන්ටිග්‍රේෂන් එක fully වෙන්නේ නැහැ එක්සැක්ට්. fully වෙන්නේ නැහැ. හදලා ඉවරලා අපි ඕනේ සබ්ජෙක්ට් කරගන්න එක තමයි ප්‍රොසීජර්. ඒක ස්පෙෂල් කේස්. okay sec cube x. අපිට මේ වුණාට මේ trigonometric functions වෙනම බලනවා. sin cos tan sec cosec cot power 1 to power 6 එතනම 36ක් බලන්න තව ඒ වගේ types තියෙනවා. ඒක එකක් විතරයි තියෙන්නේ. sec cube. Therefore you do cosec cube. Cosec cube. Especially में special points मत करती आ गए. Log functions integrate करना integration by parts. To integrate inverse trigonometry function, again integration by parts. Sec and cosec or powers. Power 3, power 5, power 7. Use integration by parts. Na? Okay. Do that. Then you try cosec cube. Do it. Okay, follow same technique. I cosec x cosec y x dx. Here take v, take here v, take here du. V equal cosec x dv minus cosec x cot x du cosec yx u minus cot x. Then we have special patterns for trigonometry functions. Sine cos similar type, tan cos similar type, cosec sec similar type. Then cosec integral type, cosec and sec similar type. And a pattern එකට යන පොඩි වෙනස්කම් කීපයක් විතරයි. Okay. අපි ඒව ගැන වෙනම බලන්න. දැන් අපි මෙතනට විතරක් පැටි ගන්නවා. Then follow uv cosec x into minus cot x integral u dv minus cosec x cot x into minus cot x dx c1 simplified minus cosec x cot x minus cosec x cot square x. Then cosec yx minus 1 minus cosec x cot x minus cosec cube x plus cosec x dx. Take here I, same I, then 2I, okay, arbitrary constant C2 minus cosec x cot x, cosec x integral minus ln cosec x plus cot x modulus plus C. Here say C1, here C2. Now divide by cosec x cot x ln cosec x plus cot x plus C. Okay, then you try sec to the power 5 and cosec to the power 5. ඒක කරගෙන යනකොට sec cube එකක් කොහේ හරි set එකේ. එතකොට sec cube මේ ආපු answer එක directly apply කරනවා මේ final line එක. මේ line එක direct apply කරනවා. sec cube එකක් integral and set. Correct? Okay, sec to the power 5. Sec to the power 5. Write sec cube times sec quad x. Then b function sec cube. Then differentiate 3 sec y x sec x tan x dx. Sec qua du function tan. Then u be sec cube tan x. Then u dv. Here 3 tan x sec cube times tan. Then sec cube tan square x sec cube. Here sec power minus 1, then sec to the power 5. 3 sec to the power 5 plus 3 sec cube. Pi, then 3i 4i. Sec cube x tan x. 3 sec cube x. දාලා මේ වගේ ගණනක් දුන්නා. ඒක ටිකක් දිගට යනවා. 3 sec cube dx. මෙන්න මේ පාර්ට් එක කලින් වල පාස් එක දාන්න කියලා මම දැන් කිව්වේ. හරිද? මෙන්න මෙතෙන්ට කලින් වල පාස් එක දාන්න. දාලා එක ලයින් එකකින් ආන්සර් ගන්න අයි සබ්ජෙක්ට් කරන්න. normally මේ ක්වෙස්චන් එක දුන්නා නම් ආලා මේක ඉන්ටිග්‍රේෂන් බයි පාර්ට්ස් වෙන්න පුළුවන්. මොකද මේක ආයේ වෙනවා ගන්න කලින් මෙතෙන්ට. ඒ විදිහට එක කම්ප්ලීට් කරන්න. तर එතන integration by parts වල අපි cases තුනක් මම මේ කරේ. හරිද? ඔයාලට මේ cases මොකක් හරි set එකෙන් එකක් එනවා. තව අපිට තියෙනවා ex times sin කට්ටිය polynomial times sin polynomial times ex. අන්න ඒ වගේ cases දෙකක් තියෙනවා බලන්න. මේ දෙක කරාට පස්සේ කතා කරන්න පුළුවන්. හරි මේක සම්පූර්ණ කරා. ඉස්සෙල්ලා පොඩි රෙස්ට් එකක් ගන්න. බලන්න ඔය විදිහටම cosec to the power 5 එකකට attempt එකක් දාන්න. दाने बदला आ रहा है एक cosec cube आप में minus substitute complete